So, welcome back to everyone. A very warm welcome to all of you guys on this NEET Simplified Success channel. Okay, I'm your physics educator, Dr. Shankar Sir, and I am here with the third session of this series of the unit and measurement, which is a very important chapter of 11th physics and one of the very important topic of the NEET physics. Okay, so I hope all the NEET aspirants who are watching this video are going well with their studies. And in this session, we are going to continue with the topic of units and measurement. Okay, I hope everything is clear till the last session, and I'm also hoping that we guys are watching all the session of the series of unit and measurement. Okay, so guys, my name is Dr. Shankar Tripathi. These are the brief credentials about me. We already have discussed it, so I'm not going to give a lot of time to it. Okay, so let's come to the point directly. So guys, in the last session, what we have seen. So in the last video, in the last live session, we were talking about the dimensions. Okay, we were talking about the dimensions of different physical quantities. What is PQ? PQ is the physical quantities. And lastly, as far as I remember, we have dealt with some many physical quantities, almost 35 physical quantities with constants. We have developed the dimensions of, and I hope we guys remember that dimensions are the power to which fundamental units are raised in order to express the unit of any derived physical quantity. Okay, so in the last session we have spoken about this. Okay, so if you haven't watched the last session, guys, please go and watch the last session first. Then only you will be able to understand this session in complete depth. Okay, so what we are going to do in this session, we will be talking about the application of the dimensional analysis. Okay, so in the last session we have seen that how we can develop the dimensions, how we can calculate the dimensions of various physical quantities. Now in this session we will be using those concepts to go further to see what are the practical applications of this dimensional analysis. So the first is, for that we first try to understand one very important concept of principle of dimensional homogeneity. See, if you understand the dimensions well, then a lot of thing you can do. And practically, as I told you previously also, that I am also into this research field. So basically, when you are good at this dimensional analysis, basically you are able to do a lot of things. What you can do, you can check the correctness of any equation. Okay, you can check the correctness of any equation. You can find out the unit of different physical quantities, different parameters involved in a equation, in a formula. Okay, okay, you can develop the formula even if you know that in certain physical activity or in certain physical law or a certain physical phenomena, if you know that these physical quantities are involved, you can also develop a formula, an expression between them. So all this you can do using the concepts of what we have learned of the dimension. But first of all, for that, okay, and obviously this method has some limitations too, so we are going to discuss that also in this session. Now, what is the principle of dimensional homogeneity? So basically, this thing you already know to some extent. If I ask you like we have a length of 4 meter, we have a length of 4 meter, and we have another length of 5 meter. Okay, another length of 5 meters. So if we add them, we will get 9 meter. Now similarly, if we have a length of 10 meter, if I subtract, let's suppose, 2 meter, it will become 8 meter, right? Now what is it? Now what I'm trying to say, so if you understand this, so the two quantities So length is a physical quantity. This length is also a physical quantity. So the quantities can only be added or can only be subtracted if they are having the same units. So this is in meter, this is in meter. So you can add it. This is in meter, this is in meter. You can subtract it. So it is a well-established phenomena. It is your basic understanding. I know that only those quantities can be added or subtracted which have the same units. Okay. Now, if I ask you that I have 10-meter length, can you add 10 minutes to it or 10 seconds to it? Right. If I ask you that we have 10-meter and please add 5 Kelvin to it, okay. So you would say, sir, how it is possible? It doesn't make any sense. How can we add time and length together? So why time and length can't be added? It wouldn't be 10-meter minute. It is nothing, right? So you cannot add the quantities or you cannot subtract the quantities which have different units or different dimensions. Different dimensions. So if we want to write it, so we can say that dimension. We can say simply the dimension of each of the term, the dimension of each of the term in an equation must be same. The dimension of each of the term in the equation must be same. Okay, so let's suppose we have an equation x plus y is equal to p minus q. Okay, so if I see in this very equation, we have a term here, we have a term here, we have a term here, we have a term here. Okay, okay, so this x could be a multiple or divisible division of any two quantities, three quantities. That is a different thing. But whatever it is, it must have some dimension. It also must have some dimension. It also must have some dimension, and this also must have some dimension. This also must have some dimension. Now, according to this principle, as we have stated previously, also with a very simple example, that only similar physical quantities, that means, and how would you know that whether a quantity is similar or not? So you will only be able to know it through its dimension or through its units, through its dimension or through its units. So we have, let's suppose, x, y, p and q. So all these terms individually, whatever dimension they are having, they all must have the same dimension. Okay. Okay, for example, if it is Newton meter, it has to be Newton meter. It has also to be Newton meter. It also has to be Newton meter, because if not, then this equation is dimensionally incorrect. Okay, okay, this is the principle of dimensional homogeneity. Okay, using this principle, you can do many things. You can find the unit of any quantity. Okay, okay. Like for example, if I say, let us come to an formula. So let me say that shear stress is equal to nu du by dy. Okay, nu du by dy. Okay, okay. So this is the formula you are going to see in the properties of fluid. Okay. So in this equation, if I ask you what is going to be the unit of this nu, so remember we have done the dimensional, we have found the dimensions of it. Okay. Now, in a way, we have applied the principle of dimensional homogeneity by default previously too. So now see, this is one term in this equation and this whole is one term, right? So these are two terms. One is coefficient of this viscosity, that is eta, or you can say nu, doesn't matter, and du by dy. Or you can say that there are three terms. One is nu, du, and dy. But now, since they are multiplied or divided with each other, it must have the same unit as that of the term. So this must be treated as one term. This must be treated as one term. Okay, and this is one term. Now, now, with the principle of dimensional homogeneity, what we can do, we can say that the dimension of nu du by dy, or let us first find out the unit. Okay, so I would say, okay, because see, in NEET, there are many previous year questions in which you are asked about the unit of other quantity. Okay, so unit of tau or unit of nu du by dy must be equal to the unit of tau. Okay, so what is the unit of tau? Unit of tau is Newton per meter square, because tau is, I am referring here to as the shear stress. Okay, the shear stress. All right, and here the unit of nu we need to get, and this du is equal to meter per second, because this is the change of velocity. And remember, the units and units when subtracted will get, you will get the same unit. It is not that the units are subtracted and it will become dimensionless. Okay, it is not going to happen like this. And it is also meter. So what is the unit of it is going to be? It is going to be Newton second per meter square. Newton second per meter square. Right. So in this way, you can find the unit of any particular any particular constant, any particular quantity, okay, by using this principle of dimensional homogeneity. And this further can be written as, so Newton per meter square is called as Pascal. Okay, so Pascal is a derived unit or a fundamental unit? The live students can tell me, is it a derived unit or a fundamental unit? Please tell me. Yeah, please tell me. So, sir, Pascal. So, Pascal is for Newton per meter square, remember, not second. So, we'll write it as Pascal second. Pascal second. Alright, guys? Pascal second. So, this Pascal is a derived unit. Why it is a derived unit, sir? Because it is Newton per meter square. Newton itself is a derived unit. Meter square is a derived unit. So, Pascal is also a derived unit. I hope you have practiced the concept we have learned in the last session. You have solved some questions from it also. Okay. Okay, so this is how, using the principle of dimensional homogeneity, you can find the unit of any particular physical quantity or constant or variable. Now, moving ahead, what kind of a questions we can, so see, as I always believe that physics can better be understood with the help of equations, with the help of problems. Okay, so let me take one NEET PYQ. Okay, so if I say that we have a equation, okay, V is equal to A plus BT. Okay, V is equal to A plus BT. So now V is equal to A plus BT, we have this equation where V is the velocity and T is the time. So what you need to do, you need to find me the dimensions of A and B. Dimensions, and let's suppose units also, of A and B. Please go for it. The live student can attempt it in the live session itself, and those who are watching the recording video, they can pause this video for time being, okay, and then can find the dimension and unit of A and B and can tell me in the comment. Okay, okay. So now I am going to do it. I hope you have attempted it. Okay. So the live student, if you want to attempt it right now, you can do, or you can just see how we are going to do it. So V is equal to A plus BT. Now let us use the principle of dimensional homogeneity here. So how many terms are there? So one term is V, one term is A, and one term is BT. Okay. So how to select the term? A plus BT combined is not a term. Okay. A is term. So if two terms are separated by a plus sign or a minus sign, they must be treated as a different term, right? If they are product, if they are multiplied, or if they are divided, combinedly they must be treated as one term. Okay, so what we can say is, so we can say the dimension of A must be equal to the dimension of B. Once we have the dimension, we can get the unit, or vice versa. We can first get the unit, then get the dimension. Any way you can do. Okay, but I'll prefer to get the dimension first. So what is the dimension of A? So dimension of A is going to be dimension of V. So dimension of velocity is going to be LT minus 1. Okay. Okay, so what can be said? We can say that. So I'll write it like this. Okay, no need of, or you can go like this. Actually, this is the proper way. L t minus one. But see, just to save time, if I write L t minus one right away, that is also fine. No worries, because in examination ultimately we have to select the right option. Okay, so dimension of A is going to be L t minus one. Now please try to understand this. So what is the dimension of BT now? Okay, dimension of this whole term. Remember what is we have learned? So we have learned that the dimension of each of the term in an equation must be the same. In an, okay, I forgot to use the correct vowel. I hope you don't mind that. Okay, so the dimension of BT, the dimension of BT the dimension of BT is equal to the dimension of BT is equal to the dimension of V. Dimension of V. Now here can I write the dimension of B, and the dimension of small t is going to be T, and dimension of V is going to be LT minus 1. LT minus 1. So this is going to be B. What is the dimension of B then? Dimension of B. So I can take this T or to the other side. So obviously it is going to be LT minus 2. I hope you know it. No problem in it. So T is going into denominator. So it will be added in minus to the numerator. I know you are intelligent. You know this. Okay. So what is going to be the dimension of B? The dimension of B is going to be LT minus 2. Okay. LT minus 2. Now, if I ask you what is the unit of A? So dimension of A is LT minus 1. So what is going to be the unit of A? If I ask you what is going to be the unit of A, so you may say, so it is very easy. For length, it is meter, because what is the SI unit of L? This is the fundamental dimension of it is meter, and this is time. So meter second to the power minus 1, that is meter per second. Now can you identify what physical quantity this A signify or represent? Any guesses? So, sir, obviously it is meter per second. So, I am very certain, we are very certain that this is representing the velocity. So, A is your velocity. Now, what is this B? What is the unit of this B? It is going to be, so for L, we are having, for B, what is the unit? So, for L, we are having this meter. For T to the power minus 2, so T is the, what is the unit to T? T is a fundamental unit. So it is fundamental quantity. Okay, so this is going to be meter second to the power minus 2. That is meter per second square. So if I ask you what is this B represent? So B represents the acceleration, because what is the unit of acceleration? The unit of acceleration is meter per second square. Change of velocity upon change of time. Change of velocity upon the change of time. So I hope it is fine to everyone. Yeah. Yeah. Please tell me. Okay, fine. Now this is representing the velocity. So you might have seen this equation: V is equal to U plus AT. V is equal to U plus AT. So this equation we are going to see when we are going to move to the second chapter of our physics subject. Okay. Okay. So V is equal to U plus A. Okay. Now let's do one more question. Let's do one more question. So there can be n number of questions that I can tell you here. So we have one question we have done. Now let's do one more question. So let me make it a little bit more tricky. So find dimension of A, B, C, D, E. Okay, find the dimension of A, B, C, D, E in x is equal to A plus BT plus CT square plus DT cube and we have further dt cube. Okay, no, let me do it like this. Let me make it a bit more tricky. E plus t. Okay. Okay, so here x is your length, and what do you think that t would be? So t would be, obviously, sir, it would be the time. Now here you need to find me what are the dimension of A, B, C, D, and E. Please try to do that. What are the dimensions of A, B, C, D, and E? Please try to do it. Please try to do it. So you have to follow the same process, the same way. Okay, so again, please solve this question before I do. I want you guys to attempt this question before you see the solution that is going to happen here. Okay, so now let me do it. If you haven't done it yet, please do solve it by your own before you see the solution to it. So find the dimension of A, B, C, D, E in x is equal to A plus BT plus CT square plus DT cube 1 E plus T. So sir, we know very easily. So what is going to be? Let us do it a bit fast. So what is the dimension of A? So it is going to be the dimension of x. So it is going to be L. Okay. Okay. Now what is going to be? And remember the dimensions are the power. Okay, so we must say the dimension of A is 1 in length. This is the right statement to make. 0 in M, that is 0 in mass, 0 in time. So we have discussed this in the last session. I hope we need not to discuss it. Now dimension of B, and this is T. So let me write the in the form of the fundamental quantity right away. So it is going to be equal to the dimension of x. So what is the dimension of x? Dimension of x, it is representing some length, some distance, some displacement. Okay, so what is the dimension of this x? So this is going to be L. So can I say the dimension of B? The dimension of B, it is going to be L t minus 1. L t minus 1. Very nice, sir. Now, what is going to be the dimension of C? Now, please see here. So, right away, this is t square. So, can I write it t to the power 2, t to the power 2, and it is equal to the dimension of x, so which is L. So, obviously, the dimension of C is going to become LT minus 2. LT minus 2. Okay. LT, so let me close it. Otherwise, someone will come up in the video and say, sir, you are not using the right way of representation. Okay, now let's move it. So, sir, how we are going to get the dimension of D and E? So, seems quite tricky. Seems tricky, is it? Is it tricky? No, sir. No, sir. It is not that tricky. Just have a look. So, see, again, we have to follow the same procedure. So, the dimension of dt cube. See, always follow the process. The dimension of dt cube E plus T is equal to dimension of x. So, what is going to be the dimension to it? The dimension is going to be x. This combined. Okay. But sir, how we are going to separate? There is something in the denominator. Now, please understand this. So, what would be, if I ask you what is going to be the dimension? What is going to be the dimension of this E? So, sir, E plus T. Now, what we have learned? So, we have learned two physical quantities can only be added or subtracted when they have the same dimension. Okay, like what we have learned. So 4 meter can be added to 5 meter, 6 meter, 10 meter. It can be subtracted from 5 meter, 2 meter, 3 meter, but it cannot be added or subtracted to anything which represents the time. Okay, which represent the dimension of the time. Okay, so what is the dimension of E? You need not to make any calculation here, and right away you can write the dimension of E is going to be T because it is added. It is added to this T. Okay. Okay. So can I write this? So dimension, what it is going to be? So can we write it? The dimension of D. Dimension of D. So I'm right away just making the calculation quickly. So this is T cube. Okay. And dimension of T is T, and this dimension is T. So it will become T square. Is it? Am I correct or wrong? No, sir, you are wrong. 4 meter plus 6 meter is going to become 10 meter. numerical value is added, unit remain the same. Okay, so E plus T, what is the fundamental unit it is going to get? It is going to get L. It is going to get the fundamental unit of T only. So what is the dimension? What is the dimension of D? Sir, it is going to be LT minus 2. It is going to be LT minus 2. Okay. Okay, so we have found now the dimensions of each and every term. We have found out the dimension of each and every term here. Now let me give you one more neat question. So these all are somewhat neat problems. Okay. Okay. Now let me give you. So find the dimension of A by B. Find the dimension of A by B in P is equal to A minus T square upon P into X, where P is the pressure, where P is the pressure. Okay, what is this P? P is the pressure. What do you think T would be? I'll leave it on your wisdom. And X, what is going to be the X? So I am also leaving it to your wisdom. Okay. Okay, so sometimes not every time they spoon feed you. No. Not every time they spoon feed you. Okay. Okay. Please see this. Please try to solve. Please do it. Please try to do it, guys. I'm very sure we can do it. No problem at all. Can we do it? Can we do it or not? Very simple question. Very simple question. Sir, we can do it. No problem at all. Now let's do it quickly. Okay. So in the examination, we have to save some time also. So what is going to be the dimension of A? Sir, it is being subtracted by T square. So since it is subtracted from the T square, it must have the same dimension as that of the T square. So what is going to be the dimension of A, sir? So it is going to be T square. It is going to be T square. Sir, right away, what will be the dimension of B? So dimension of B is going to be equal to the dimension of X. Okay, there's nothing like that. Please try to understand it. This is not the right thing to do because this is not added or subtracted. Okay, so two quantities, when they are multiplied or divided, their units too are multiplied and divided. Okay, their units too are multiplied and divided. Like for example, velocity is equal to change in length upon the time. So what is the unit of the length? It is meter. What is the unit of the time? It is second. So the unit comes out to be meter per second. Okay, so you cannot get the unit of B right away. Okay, but you can get the unit of A right away. Now again we can follow the procedure. So the dimension of A minus T square upon Bx is going to be equal to the dimension of the pressure, that is P. Okay, so now what is the fundamental dimension of the pressure? So now please try to think it in your mind, because see, we have to save some time also. So I told you to memorize the dimension of the force. So what is the dimension of the force? So it is ML T minus 2. And what is pressure? Pressure is force upon area. Pressure is force upon area. Okay, so this is the unit of the force divided by what is the unit, what is the dimension of this area? It is L square. So this divided by L square, that means we are going to get M L minus 1 T minus 1. We are going to get M L minus 1 T minus 1. Okay, sorry, T minus 2. Okay, so if you go in the previous session, we have derived the dimension of the pressure. So from there also you can do, but I would prefer that rather than memorizing, you can do it in your mind. Such simple calculation. Now, see, what is the dimension of A minus T square? This whole term will have the dimension of T square, right? This B dimension we have to find, and what is going to be the dimension of this X? The dimension of X is going to be L. The dimension of X is going to be L. So what is going to be the dimension of B? What is going to be the dimension of B? Dimension of B, so sir, it is going to be, so if we take B on this side, what is, so T square minus 2, so first of all L minus 1 into L, it will become L to the power 0, that means that the L is gone now, and this M upon, so it is going to be M minus 1 and T to the power 4, T to the power 4. Okay, is it fine? So I just have done some cross multiplication. So this is going to be the dimension of B. Now we are asked about what is the dimension of A by B. So the dimension of A by B is going to be T square upon M minus 1 T to the power 4. T to the power 4 is equal to M T minus 2. Okay, so the ratio of A by B, it is going to be MT minus 2. I hope it is fine to everyone. Okay. Okay, so this is how we can play with the dimension. This is how we can apply the principle of dimensional homogeneity to find the dimension of various parameters involved in an equation. Okay, so do you want to do some more questions? So let's do one. Okay, this is again the NEET question. Okay, so see, as I promised to you in the, in these sessions itself with the topic, I want this. If you watch these videos, like units and measurement, if you watch, you don't have to watch from any other source again. You don't have to run for questions here and there. Okay, so this is one stop solution for you, right? I hope you are enjoying the session. So alpha in, so you have to find the dimension obviously of alpha in P is equal to P naught e to the power minus alpha T square. Okay, okay, and in this question there is no mention what is P. Don't know. We don't know what is P. Okay, we don't know what is P naught. Okay, literally we don't know. Okay, in the question itself it was mentioned. If you see the previous year question, I believe it is a question of, I think, NEET 2018 or something. So P we don't know, it wasn't given. P naught is not given. The T square, sorry, the T is given, that this is representing you the time. So you have to find the dimension of alpha. You have to find the dimension of alpha here. Okay. Okay. Oh sir, oh my god, this is e to the power something. How we are going to get the dimension of it? Please think. See, common sense, if you apply your common sense, you will get your answer. Concepts are the same. There is nothing in this concept that you don't know. You certainly know the concept, you certainly know everything. It's just the matter that if the right thing clicks in your mind at right time. That's all. Please try. Please try. I'm quite sure we can do it. Please try. I'm very, very sure we can do it. So, how can we do it? So, alpha in P is equal to P naught e to the power minus alpha T square. So, here we need to get the dimension of alpha. Now, please try to understand this. So, e to the power something. If I say 5 to the power 4, okay. So, if something is in the power of something, it is a numeric value, no? So, whatever alpha T square must be, it must comes out to be a number, or it must come out to be a numerical value. Do you believe it or not? So, anything which is having any number, any constant, any variable, so if it is having something in the power, it must be a numerical value, right? It must be a numerical value. So this minus alpha T square, at the end of the day, it must be a number. It is purely must be a number. So it was ending up to be a number. Now what does supposed to mean? So what is the dimension of a number? If I ask you what is the dimension of a number 5, what is the dimension of the number 10? So you can say that it is a constant. It is a constant, and this constant has no dimension. Any number has no dimension. So what I can say, now please don't end up. So you will see an option that what is the dimension of alpha. One option would be given that dimension of alpha is dimensionless. That is, alpha has no dimension. That means the dimension of alpha is M0, L0, T0. So these kinds of options are given to trigger some sort of confusion in you. Okay, so don't get confused. See, it is very simple. This is a number. So that means that dimension of alpha t square minus we have nothing to do with. If you want to write that minus also, that is fine. So dimension of alpha t square must be, it combinedly must be a dimensionless entity. So it must be M0, T0, L0 or ML0, T0, whatever you want to write. Okay. Okay. Now, what is going to be the dimension of alpha? So the dimension of T square is going to be like this, and this is M0, T0, L0. So we may, okay, we may write it like this now. Okay. So always prepare your own notes. Right. It is always advisable. See, you can get the note downloaded. Whatever I'm teaching you, this note is could be downloaded. You will get the description. You will get the link for the PDF in the description. Okay. But it is always advisable that you make your own notes. Okay. Your own notes are the best notes that you can ever have. Okay. Okay, so alpha, what is the dimension of alpha? It is going to be M0 T minus 2 L0. Right? Right? I hope it is fine to everyone, and it is perhaps sometimes written as like this one. Okay? Okay, but as we have stated in the last session also, that generally, not, not, it is not some sort of a law. Generally, we represent the dimension of any quantity in terms of mass, length, and time. This is the standard that is usually being followed. Okay, for any group, I don't. Okay, and we are not interested in knowing also. In competitive examination, what we know also is very crucial for our selection. Unnecessary knowledge is also harmful sometimes, right? Now let's do one question. So how many questions we have done? I think 1, 2, 3, and 4. 4 questions we have done. So this is the question number 5. Again, NEET PYQ. Okay. So this is beta. Find the dimension of beta in P is equal to alpha by beta. P is equal to alpha by beta e to the power minus alpha z upon k theta. Okay, minus alpha z upon k theta, where we are having P is equal to pressure, P is equal to pressure, okay, Z is equal to distance or displacement, doesn't matter, okay, K is equal to, theta is equal to the temperature, okay, and K is equal to is Stephen Boltzmann constant, is Stephen Boltzmann constant, Boltzmann constant, and the unit of it you must know though. So in the last session we have we have formulated the unit of Stephen Boltzmann constant, we have formulated its dimension, but for your E I am going to give you the unit of it. Okay, so the unit to it is kg meter square per second square Kelvin. Okay, second square Kelvin. Now you can get me the dimension of beta in this equation. P is equal to alpha by beta e to the power minus alpha z upon k theta. Please try to do it. I am very sure we can do it. No problem at all. Please go for it. Please go for it. So how can we do it? How can we do it? Now, one thing. So I hope all of you are attempting these questions before I do. Okay. 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 Right. So you must always do the question. You must attempt it before I solve it for you on the screen. Okay. So here, let's do that. So what is the dimension? Can we write dimension? So e to the power something. So whatever in this power must be a number. So can we write alpha z k theta it must be a dimensionless entity. So M0, L0, T0. Okay. Okay. Now here we can get the dimension of alpha. Why will be needing the dimension of alpha? Because obviously the dimension of alpha by beta is going to be equal to the dimension of P. So to find the dimension of beta, we shall be requiring the dimension of this alpha. The dimension of this alpha. So what is the dimension of this alpha? So we can write, so the dimension of this z is L. Now please see. So the dimension of k, so kg, for kg we have m. For meter square we have, L square. Then for T we have T minus 2, and for this K Kelvin, that is, so we can use K only. So it will become K minus 1. Okay, K minus 1. Okay, okay. And then we have this theta. Then we have this theta. Theta is temperature. So theta is temperature. That means we are having it K here. Having one K here. So it is M0, so M0, L0 and T0, right? M0, L0, T0. So very, very easy, So this LL, so from here we can get the, the dimension of alpha. So let me right away write it. So see, K minus 1 K are going to get cancelled out. Okay, no problem, sir. This L and L square, so we'll left with one L only. And this is going to become T minus 2. T minus 2. So what we are going to have? We are going to have the dimension of alpha as MLT minus 2. Now, what is the unit or what is the dimension of this beta? What is the dimension of this beta? So alpha is MLT minus 2. Now we understand that the dimension of alpha by beta must be equal to the dimension of P. Okay, dimension of P. So from here, can I write? So what is the dimension of alpha? We just have got. See, now you can speed your calculation up. So MLT minus 2 and upon the dimension of beta is equal to the dimension of P. So we just have calculated the dimension of P. It is ML minus 1 T minus 2. ML minus 1 T minus 2. In the examination, you don't need to remember the dimension of pressure. Okay, you can have it derived in just one line, and sometimes you can do it just in your head only. Okay, okay. So from here we can write what is the dimension of beta here. So the dimension of beta is going to be, see, cancel out, T minus 2 cancel out. So beta goes there, L comes down. So L upon L to the power minus 1. So the dimension of beta is going to be L square. Very, very simple, sir. Very, very simple. Now, who is up for one more question? Let me do one last question. One last question, one last type, so that everything to be in your mind. And don't worry, you just have to study this, what I am teaching you. Nothing is going to be outside from this in this very chapter. Okay, with full responsibility, I'm telling you that. I'm trying to take up each and every kind of question. So let's have y sine omega t minus kx. Okay, so here you have to find the dimension of, so let me write one thing, A. Okay, so the dimension of A omega and K, A omega and K, where T is the time, okay, and Y and X are displacements. Y and X are displacements. So the live student can respond to me right away. They can respond to me. Please try to tell me. Please try to tell me what is the dimension of A omega and K. Sir, we want to call it W, a small w, and that's okay only. If you want to call it W, that is okay. If you want to call it anything that you want, that is also okay. No problem at all. No problem at all. So, are we solving it? Any live student who want to answer me here? Now, please observe. Y is equal to A sine omega t minus kx. Now, right away I can write something. Please understand this. So, dimension of A is equal to the dimension of Y Sir, how you can write that? So sine omega t minus kx. Okay. Now this omega t minus kx, it must be some angle, no? Ultimately, it must be some angle. Now, if this whole thing is an angle, this must also representing an angle, and this must also be representing an angle. What else could be in sine, if not angle? Obviously, sir, if we have sine theta, if we have cos theta, if we have tan theta, if we have cosec theta, if we have cot theta, anything like that, that theta is angle only, no? If I say sine theta 1 minus sine theta 2, so theta 1 and theta 2 are the angles only, no? Right? Okay, so here, this and sine of any angle must be a number. Okay, and number has no dimension. So it means the dimension of A is straight away the dimension of Y. So we can write the dimension of A is equal to L. The dimension of A is equal to L. Okay, okay, and can we write like this? So dimension of omega t. Dimension of omega t is equal to dimension of angle. And what is the dimension of angle? Sir, we have learned from you, we have learned that angle is a supplementary quantity. And supplementary quantities are the only quantities in this world of physics which have units, but they do not have any dimensions. I hope you remember that. So dimension of omega into don't consider it as weight. Okay, sometimes people write weight like this. No, WT dot. This is not weight. This is not weight. W, that is a small w, or you can say it as omega into t is equal to the dimension of angle. So angle is dimensionless. So we can write m0, we can write l0, we can write t0. No worries, sir. Now the dimension of t, the dimension of t is capital T, so it goes that side, so it will become t to the power minus 1. T to the power minus 1. Okay, okay. Now, so what physical quantity it could be? Sir, it could be angular velocity, it could be frequency, or it could be angular frequency, because they all enjoy the same dimension. Okay, okay. Now, if you see, there is one limitation, if you can observe here, that you can't comment whether it is a frequency or whether it is an angular frequency. Are you getting my point? Okay, okay. Though you would say, if you apply some more logic, that's it, it definitely must be radian per second, because ultimately it must be a angle. So if omega, nothing this way, omega is radian per second, time is second, second will be cancelled out and it will be radian. Okay, so like as more you practice, you will come up with more and more logics. You will come up with more and more logics. Okay, okay. So some limitation dimension analysis do have it, get you confused sometimes that what could be that physical quantity. Now same way, what is the dimension of kx? So the dimension of kx is again is going to be, this is an angle. An angle is dimensionless, so we can say it is going to be m0, l0, t0, and this is going to be dimension of k, so it is going to be L to the power minus 1. L to the power minus 1. Now, if you want to think, see, if you are getting confused to it, that doesn't matter. Now, k into x. Now, k into x is some sort of a displacement, and it has to be angle ultimately. It has to be angle ultimately. So, what could be the unit of k? It must be radian per meter, right? Radian per meter. Radian is dimensionless per meter, so that means L minus 1. So sometimes, see, with practice, see, more, first of all, you must understand the concept. Okay, once the concept is understood, you can evolve, like we do biology, no? Harsh sir and Khadija ma'am is teaching you that, right? So as in biology, the things evolve. Now, same way, as I speak in terms of biology, we human beings have a nature to evolve as well. So in the study of physics with practice, with good understanding of concept, you will evolve by yourself, right? Ah. So now I think this much is fine. There are n numbers of more questions, and I'm very sure that if you have watched till this point, in continuation, you are going to deal with all of it. Okay, okay. Now I was speaking of. So this is what we call as the principle of dimensional homogeneity, and I have given you some use of it. Now, further, if I you see that what is the application of dimensional analysis, what is the of further application of dimensional analysis, So, what we can do. So, what is the further application to dimensional analysis? So, the further application to dimensional analysis could be checking the correctness of an equation. Checking the correctness of an equation. Okay. Now, please understand this. After you learn this, after you watch this video for more 15-20 minutes more, you would be able to now judge whether the equation provided to you is correct or incorrect. How wonderful it is now. But you need not to be very happy, because see, you are not going to become the scientist today. Why it is so? Because you can check. You can check the equation, the correctness of equation to a very basic level. You cannot check the correctness up to a certain level. How? I'll just show you. Let me think of an equation. Let me think of a basic equation. So S is equal to ut plus half at square. Oh, sir, we haven't seen this equation. Don't worry. In the next chapter, after unit and measurement, we are going to start with the motion in the straight line. First part of kinematics. Okay, there I am going to tell you how to use this equation. I am going to get you derive this equation. Nothing to worry about. Just follow. Okay, just follow my lead. Everything is going to be completed. Everything is going to happen. There is nothing to worry at all. Okay. Okay. Now please observe this. Now we have to check the correctness of this equation. So how we can check the correctness of this equation or any equation? Please understand this. For any equation, this is how this law speaks. So for any equation to be correct, the dimension of left hand side must be equal to the dimension of the right hand side. Now, previously, by assuming this, we were applying the principle of dimensional homogeneity. Okay. Okay. So, how, sir, this is different from what we were doing till now? So, till now, what we were doing, we had some quantities. We were trying to develop. Okay. Okay. We were trying to develop the dimension of each of the variable. Here, we pre-assume that thing, and we are trying to see whether the equation is correct or not. And again, I am repeating myself, we can check it only at the basic level. So the dimension of LHS, so I can write the dimension of each term in LHS is the dimension of each term of RHS. So if this happens, you can comment that the equation is dimensionally correct. Okay, now let's do it through the question. Let me consider this as the question number 1. So SUT plus half AT square. Okay, now someone has proposed you this relation. Now see how this topic can help you memorize the formula, can help you if see when we study a lot. Now if I speak of this time, many of you might have just started your NEET preparation. Okay. Okay. So right now, since we have started the NEET preparation, we have very less content in our mind. Now, with time, what is going to happen? You will read, you will learn the next chapter, you will then study the next chapter, you will next study the next chapter, you will next study the next chapter. So all these chapters that you are going to study further, you are going to gain some more concepts. Okay, so when the NEET examination is going to happen at that day, there are so many concepts are going to be there in your mind that it is going to be very difficult for you, or moderately difficult for you to memorize all these formulas. So at times this topic helps you even to check whether the formula came out of your mind is correct or not. Are you missing a word? Are you missing a quantity? Are you missing some variable? So these kind of things also you can get help from this topic. Now please understand this. So dimension of each term of LHS. So what is the, so if let's first speak of the LHS. Let us do it quite conventionally. In the next question we can speed it up. So in the LHS, we have only one term. So dimension of S is equal to L. Okay. Okay. Now let's talk about the RHS. So what is the dimension of UT? Dimension of UT. So what is the dimension of UT? So U is the initial velocity. Okay. So this UT, what is U, what is T? This shall be provided. So S is the displacement. Okay. I forgot to tell you. Let me tell you now, but I assume that many of you must be knowing it beforehand. So S is the displacement, U is the initial velocity, A is the acceleration, T is the time. So U is the initial velocity. So what is the dimension to the U? It is going to be, what is the dimension to the U? It is going to be LT minus 1. What is the dimension to this T? It is going to be T. So the dimension of UT is going to L. So the dimension of this is L. You can do like this. The dimension of this hole is L. Now let's see the dimension of half AT square. So half is a number. It is a constant number. It has no dimension. Very well. What is the dimension of A? It is going to be LT minus 2. What is the dimension of this T? It is 2. So it is going to be L. This is going to be L. So the dimension of this is also going to be L. That means the dimension of each term of LHS and the dimension of each term of RHS are the same only. Now, dimension of each term of LHS and dimension of each term of RHS are same only. That means that this equation is dimensionally correct. This equation is dimensionally correct. Okay. Okay. Now, sir, I hope this is fine to everyone. How to check the correctness? So, these kind of a question you will get in your examination, that they will give you some random equation. Normally, they don't give you the equation you usually know. So why, sir, you have given us this equation? So I have given you this equation because I wanted to keep it simple, because this was the first question. I'll raise the bar with more questions. No worries about that. Okay, so S is equal to UT plus half AT square. So the dimension of each term on left hand side, dimension of each term on the right hand side are equal only. Are equal only. No problem at all, sir. No problem at all, sir. Okay. So this is dimensionally correct. Now, what is the bottleneck here? What is the limitation? Now, if I write, now please understand this very, very carefully. Now, this is the correct equation as UT plus half AT. So, sir, how you are saying this is correct equation? Because I know it, no, already beforehand. But if suppose for 1 minute that I didn't know this equation, so can I check whether this 1 by 2 is correctly mentioned here? Can I check? Can I check the correctness of this? Check correctness of it. So guys, of this. Okay. Okay. So I can't. We can't do this through dimensional analysis. Okay. This is the very limitation of this dimensional analysis, that you cannot check the correctness of numbers. Okay. Instead of half, if it would have been written here 10, if it would have been written here 1000, if it would have been written here any number, if it would have been written here no number, then also you will get to say that, sir, this equation is correct only because you can check the dimensions only. Okay. So remember, any term which do not have any dimension, you cannot check the correctness of that by using the dimensional analysis. So this is one limitation of this dimensional analysis. That is why I said to you that we can check correctness of an equation, but to a very basic level. We can't check the correctness of an equation to a high level. Okay. Okay. So we can check the correctness of equation to a very basic level. I hope this is fine to everyone. Now let's check the correctness of some more equation. So we have t is equal to 2 pi root over L by G. We have t is equal to 2 pi root over L by G. So the live student can check me the correctness of this equation. The correctness of this equation. Okay. So we know this is correct only. This is the equation of the time period. Okay. Don't just, if you know it also, just try to think in a way that you don't know it. Right? You don't know it. You want to check the correctness to it. Right? In your school exams, in your board exams, these questions are definitely there. Isn't it? Okay. Now I hope that you have already checked it. So how we can check the correctness of this equation, sir? So we can check the correctness of this equation by seeing the dimension of the left hand side, seeing the dimension of each of the term on the right hand side. So let's do it very quickly. So left hand side, what is the dimension here? The dimension is L. Now this 2 pi has no dimension. Now let's check the dimension to this. So the dimension to this is root over L by G. So root over L by G. So the dimension of this L is L. The dimension of G is L. T minus 2. L T minus 2. So what it is going to become? It is going to become T only. Okay. So see how it is going to become T only. The L will be cancelled out. T to the power minus 2 will become T square. T square then inside a under root sign will become T. So the dimension of this is T. Okay. Now the dimension of right hand side, dimension of left hand side are the same. So this is a dimensionally correct equation. This is dimensionally correct equation. But I'm asking you here, you can answer me in the comments. Can you check the correctness of this 2 pi? Whether this 2 pi is correct? Whether this 2 pi is correct or not? Can you check the correctness of that from this analysis? No, sir. We cannot check the correctness of that from this analysis. Why so, sir? We cannot check the correctness of this from this analysis because we do not have any way to check the correctness of it. Because it is a constant, it is a dimensionless quantity. Instead of 2 pi, if it would have been, instead of 2 pi, if it would have been 4 pi, if it would have been cos theta, if it would have been sin theta, if it would have been anything else also, you would not be able to find the correctness of that because these are dimensionless. Okay, so through this analysis, you cannot check the correctness of any dimensionless entity. I hope it is fine to everyone. Now let's move to one more question. Now I want you to check this. So we have H is equal to R rho G upon 2s cos theta. Okay. So here R is the radius. Okay. Here R is the radius. Rho is the density. G is the acceleration due to gravity. G is the acceleration due to gravity. Okay. S is the surface tension. Surface tension. And theta is an angle. Okay. Theta is an angle. Okay. We call it angle of contact. Right. Now you have to check whether this equation is dimensionally correct or not. Please try to do that. Please try to check whether this equation is dimensionally correct or incorrect. Let's see if we can do it. Let's see if we can do it. See, we have to go for the same way. Very simple. Very simple, guys. Please try to do it. Please try to do it. H is equal to R rho G 2S cos theta. Let's see how we can do it. So, sir, again, sir, we can follow the same process. I hope, again, I'm saying you must solve, you must attempt all these problems before I attempt it. Okay. So, what is the dimension of H, sir? This is going to have the dimension of L. Okay. Dimension of L. What is the dimension of this whole thing? Now, what is the dimension of R? Sir, it is radius. Dimension of rho. So rho is kg per meter cube. So we have m L minus 3. Okay, wonderful. G is acceleration. So meter per second square, that is LT minus 2 upon 2s. Okay. Sir, we don't remember the dimension of the surface tension, though we have calculated it, though we have seen it before. Okay, but it is okay if you don't remember. Sir, we remember the formula. Okay, at least one thing you must remember. Either you must know the formula, either you must know the unit. Okay, if any of it is known to you, you will get the dimension. Okay, so we know that surface tension is force upon length. Okay, force per unit length. Okay, it is the property by virtue of which a fluid element tries to minimize its surface area. So, from where this came from, don't worry, we are going to see it when the right time is there. Okay, so surface tension is force. What is the dimension of the force? MLT minus 2. MLT minus 2 upon length, that is L. So LL is cancelled out, so it will become MT minus 2. MT minus 2. Right? Okay, so this 2 has no meaning actually here. Okay. T has no meaning here though, but that's okay. So what we can do here, so we are getting this now. Please observe. So see, right away without writing, we are doing just like we do in the examination, or we must do in the examination without wasting the time. Okay, okay. So we have it as L minus 1. L minus 1. Now here the dimension of left hand side is L. The dimension of right hand side is L minus 1. So is this equation correct? Now straight away you can say this equation is incorrect. This equation is incorrect. Why it is incorrect? Why it is incorrect? Because the dimension of the terms on left hand side is not equal to the dimension of the terms on the right hand side. The dimensions of the terms on the right hand side. I hope it is fine to everyone. So this equation is dimensionally incorrect. Okay. Okay. So now sometimes what happens? Now can you, so just take 1 minute, and can you suggest me that what could be the right equation here? Can you suggest me that? What could be the right equation here? Meanwhile, I'll take some water. Please tell me, what is the right equation? What could be the right equation possibly? What could possibly be the right equation here? Anyone? Anyone? Now, sir, obvious. Now, please understand this. This is why I say that this chapter sometimes is, work as a hack also. Okay, it is very useful sometimes to even knowing the formula. So sometimes what I have seen that when we have this tendency of forgetting, a normal tendency of a student is that he get confused between numerator and denominator, and sometimes in many formula we interchange the numerator and denominator. Okay, so the denominator goes up, numerator goes down. Okay, now in those cases also, if you have a slight confusion, you can do this analysis in a minute and can check the equation. Okay, now this is coming out to be L minus 1, and if this equation is to be correct, if this equation is to be correct, what shall be the dimension? The dimension should be L. So obviously if you use some of your common sense, you would be saying that's the only thing we have to do. We can reverse this equation. Okay, this is the right equation where we are going to say it. So this is the equation of capillary rise. Okay, so when a small diameter tube is immersed in a liquid, may it be water or mercury or any other liquid, the liquid has a tendency to rise in that small diameter tube. Okay, this is the concept from the fluid. Okay, so we'll talk about it when the times come. But right now we had a wrong equation, a wrong formula with us. But what we have done? What we have done, sir? We have we have found the right expression using that dimensional analysis, and we come to understand that initially the equation provided to us was wrong, and to find the correct equation, what we had to do, we just have had to reverse the original one, reverse the given. So this is the way you can check the correctness of the equation. So two things we have done till now from the dimensional analysis. First of all, we found the dimension of some variables, some entities given to us in the equation. Now, secondly, what we have done, we have checked the correctness of any formula, any equation using the dimensional analysis. Now, this has further applications. Two applications are left basically. So, what are the further applications? So the further application to it is conversion of units. Okay, conversions of unit. Okay, so basically, if you want to convert the unit of any given quantity into some other system, like for example, that you have some quantity in SI unit and you want to convert it into CGS or vice versa, you can do by this method also. You can do by this method also. Okay. Okay. Although I'll recommend that you never do this with dimensional analysis, because if you try to do it directly, that will be more beneficial. But just for the sake of understanding, that's how we do it. Let's do some. So see, it is very simple. So physical quantity, in the very beginning we learned that for a physical quantity two things are required. One is the numerical value, other is the unit. Okay, okay, okay. Now let's suppose in one system of dimension the numerical value is n1 and the unit is u1. Okay, and in other dimension system, in other unit system, the numerical value is n2 and it is u2. It is u2. Okay, like at times we represent 1 meter is equal to 100 centimeter. So both are the same thing only, na? Okay, so 1 meter, one is the numerical value, m is the unit, 100 is the numerical value, centimeter is the unit. Okay, but they both represent the same. Now, in the same way, you can do it. So let's do a problem or two for our better understanding. So now we need to convert, let's say, convert. Okay, so this is more helpful, those who are studying in 11th class. So when they write your board, pre-board, class test, quiz, okay, there it is going to help you more. Okay, because in those specifically they write that do it with the dimensional analysis. Okay, okay. So those cases in NEET examination is not very advisable to use this, because it is certainly a long process, but still we have to do one or two problems. Okay, so now we want to convert Newton into dyne. Newton is what? Newton is in SI unit. Newton is the SI unit. Okay, what is this? Dyne. Dyne is in the CGS unit. Okay, so now 1 Newton is kg meter per second square. We know it. Mass into acceleration. Okay, so mass into acceleration. So mass is kg, acceleration is meter per second square. So in CGS, so in the CGS system, basically instead of kg, we use this gram. Instead of kg, we use this gram. Okay, instead of meter, we use centimeter, and instead of second, we use second only. Centimeter, gram, second system. Okay, okay. So gram centimeter per second. So, sir, we can convert it right away, no? Like in the NEET examination, how to do it? In the NEET, for NEET, okay, because we are here interested in NEET more. So for NEET, we can right away convert, no? Kg meter. So for 1 kg, we can write 1000 gram. For 1 meter, we can write 100 centimeters. So here we have kg is converted to gram, meter is converted to centimeter. Second square remains second square, so it is 10 to the power 5. This is how we do it, no? In general, this is how we do it, converting the unit from one way to other. So right away we can write 1 Newton is equal to 10 to the power 5 dyne. Okay. So if in the NEET examination you get this, you do like this. Okay. But just for the sake of knowing the process, that how we can do it from this process, I'll tell you the way. So it is very, very simple. So we are doing it again, just conventionally. Just one question I'm going to give you. Okay, so now how we can do it? See, please observe. So we have MLT minus 2. So from where this came from? So the dimension of the Newton or the force is MLT minus 2. Now how we can do it? So please observe. So we have to apply this one. N1 U1 is equal to N2 U2. Okay, so N1 U1 is equal to N2 U2. What is the N1? So N1 is 1. Okay, U1 is what? U1 is the M1, let's call it M1 L1 T1 minus 2. M1 L1 T1 minus 2. And N2 we need to find. Okay, and what is the unit 2? So let's call it M2 L2 T2 minus 2. Just follow the process, nothing else. Okay, so here for the first way of representation, for first system of units, I am using the subscript 1. For the second system of unit, I am using the subscript 2. So what is M1? M1 is kg. Okay, M1 is what? M1 is kg. Sir, L1 is what? L1 is meter. T1 is second. Now same way here, M2 is gram. L2 is centimeter and T2 is second. Okay, T2 is second. Now we understand that. Just a moment. So now we understand that N1 U1 is equal to N2 U2. N2 U2. So N1 is 1. U1 is M1 L1 T1 minus 2, okay, is equal to N2 into U2. U2 is M2 L2 T2 minus 2. M2 L2 T2 minus 2. So from here, N2 is M1 upon M2, L1 upon L2, T1 minus 2 upon T2 minus 2. T2 minus 2. Now let us put it. So M1 is 1 kg. M2 is 1 gram, L1 is 1 meter, L2 is centimeter. This is second minus 2, this is second. Oh, sir, it is so long a process. That is why I told you that never use this. This is the conventional way, no? So 1 kg is equal to 1000 gram. Ultimately, you have to do that only. 1 kg is equal to 1000 gram. 1 meter is equal to 10 to the power 2 centimeter. So here kg will be cancelled out. So see, we have converted kg into gram. So or if you want to go for one more step, so 1 kg is equal to 1000 gram upon 1000 upon gram. This is 100 centimeter upon centimeter. Okay, and second minus 2 will be cancelled out obviously. So ultimately what we are getting? So 1, 2, 3, 4, 5, 5 zeros. See, gram, centimeter will be cancelled out. So N2 is 10 to the power 5. N2 is 10 to the power 5. So what we can write again? 1 Newton is equal to 10 to the power 5 dyne. Okay. But I again saying I never advise this way. I never advise this way to go for the NEET examination, because this is conventional way. Na? Right away you can do that. Right away. Because see, in the NEET, in any competitive examination, when you have options, okay, the examiner or no one is interested in knowing that how you have solved it. How you have solved it. No one is interested. Okay, the only interest people have, or we have, or you have, or the checker is having, or that top medical college is having, that whether you have selected the right option or not option. However way you have selected that, however way you have done that, no one is interested. Okay, now let's do one more question. This is also a neat question. So G is 6.67 into 10 to the power minus 11, and it is unit is Newton meter square per kg square in SI unit. In SI unit. Okay? In SI unit. Now, what will be the value of G? What will be the value? What is G? G is the universal gravitational constant. So we are going to see it when the time comes. What will be the value of G in CGS unit? What will be the value of G in CGS? Can you please tell me that? Can you please tell me that? The live students. So how we shall do it? So shall we do it with this conventional way? Shall we do it in this conventional way, guys? No, sir. We shall not do this in this conventional way. Sir, how shall we do it? So we shall be do it straight way. No. So in the CGS unit, so CGS, so 6.67 into, so first of all, convert it. So Newton is kg meter per second square into meter square upon kg square. Let's do it. So we have meter cube upon second square kg, right? Meter cube into second square kg square kg, 1 kg will be cancelled out. Now let's have it converted right away. 6.67 into 10 to the power minus 11. So we want to convert it into what? Into gram and centimeters. So meter cube. Let's convert it into the centimeters. So 100 cube it will become. 100 cube. Okay. Okay. 100 cube centimeter cube. Second square, let it remain like this. And 1 kg is 1000 grams. Okay. 1000 grams. So how much it is going to become? It is going to become, so if I'm just converting the unit here, okay, this value I'm keeping like this. So this will become 10 to the power 6 upon 10 to the power 3. So see, when you convert this meter cube second square kg into 10 to the power 3 meter cube upon second square, sorry, it will become 10 to the power 3 1 meter cube per second square kg. Or if you are getting confused there, no worries. I'll just do it. Okay. So here, this is the unit. I'll just write it like this. So I'll just write it here. No worries. 6.67 into 10 to the power minus 11. So this meter cube, converting it into centimeter. So it will become 10 to the power 6 centimeter cube. Second will remain the second, and kg, to convert kg into gram, 1000 will 1 kg is equal to 1000 grams. So how much it is going to become? So 10 to the power 6 divided by 10 to the power 3. So we are getting 10 to the power plus 3. So ultimately it is going to become 6.67 into 10 to the power minus 8. 10 to the power minus 8. Now Newton meter square kg square. Okay, so you can convert it into centimeter cube second square per gram square. I hope it is fine to everyone, right? Okay, so this is how you can convert this value into the CGS unit. Into the CGS unit. I hope it is fine to everyone. Any doubts? Okay, very, very simple, sir. So, sir, we want to do it with this conventional way as you have done in the previous question. So, you may do it in the same way, because though I'm not recommending it because it is a lengthy method, we have to save the time as well. Okay. Okay. So what is the next, next application? So basically, one application is left there, and I'm just mentioning it today. We are going to have it discussed in the next session. Okay, because the session is getting too long now. So the relation, deriving the relation between, deriving the relation between physical quantities in a physical phenomena, in a physical phenomena. So what we are going to do into it, so basically see, so talking about it in the form of experimentation, let's suppose you have conducted some experiment. Okay, okay, you have conducted some experiment. Okay, you wanted to know that, so you must have done this in your or you may do it in future, or you might have done it. So a very popular experiment is there. Every 11th 12th 11th student do it in their laboratory. So you find the acceleration due to gravity using this pendulum setup, right? From where this came up. So let's suppose that we are doing some experimentation. Now, if we are knowing that what are the parameters involved in that very experiment, okay, you can develop the formula, the relation amongst those physical quantities, those variables using the dimensional analysis. Okay, okay. So how we are going to do that? We are going to solve some questions. So from here, a lot of questions in the NEET happens to be, okay. A lot of question came from this in the NEET examination. Okay, okay. So we can do it in the next session. Okay, and we are going to further continue with the topic of significant figures. Again, a very important topic for the NEET physics. Right. So guys, that will be all in this session. Okay, so I would say thank you. Those who have watched it, those who are about to watch it, those who are never going to watch this video, for to all, thank you very much. And also, please subscribe this channel. Please share this to your friends so that everyone is benefited. Okay. Okay, so let's see you in the next session. Don't forget to subscribe. Have a good day. We'll see you in the next session. Thank you very much.